Hello, so we are Julia and Ivan, and we are the team who has worked on the recovery of the indoor light energy with photovoltaic cells. It was under the guidance of Bastien Politi and Raphaël Clerc. So first of all, I will contextualize our subject, explain the goal, and introduce the protocol and the results. And we will talk about the analysis and the conclusion. So the sun is quite an infinite sources of energy. And someday we decided to recover and capture the light. So consequently, we created photovoltaic cells and panels. But we always need more energy. So we needed to find other way to produce and capture the energy. Unfortunately, the photovoltaic cells recover also artificial light. So it is what we did during the lab work. And so our goal was to find the best condition with the different parameters. So now I will talk about the protocol. Yvan, so we had different light sources, especially LED, halogen, and flow compact. And we had different photovoltaic cells like the regular one with silicium and the flexible, for example. Finally, we had different tools. For instance, an algorithm created by Bastien, different software like Spectra Suite and Ocean Optics, and other tools like photodiode or photo spectrometer. So we use different conditions in order to find the best capture of light. So we varied the different parameters. So the sources, the cells, and the distance. Indeed, we made measurement for each cells at different distance, and each time with the three different sources. So if we superpose all the spectrum of the sources, we can see that the halogen has the biggest area and emits the most. So this is a result that which will be interesting for the analysis.
Okay, so now I'm going to talk about the IV characterization of cells. So PV cells react to an incident flux of light, and this light is proportional to a tension, and so the tension applied to the cells produces a current which we use to characterize and to do the characterization of PV cells. And in order to have the power emitted, the power produced by the cells, we have to multiply the intensity by the voltage of the IV characterization. And we have this type of graph, such as with the halogen. So power emitted by the cellule 3, and we have different other power. So the first thing you can see on this graphs is that this power normalized by square meters, but it is to compare the different cells because the cells are not do not have the same dimensions, and we need to compare it. So this is why we normalize the power. And the thing is that the incident flux is not constant for halogens and flow compact. So this is why we needed to do calculations and average power. So this is what we did. We used on MATLAB different tools to make an average power in order to access the efficiency of cells, of PV cells, and in order to after keep the best conditions to the user in order to have the greatest efficiency. And on the right, you can see an agreement between theory and experiments that the irradiance is proportional to 1 divided by d squared, d the distance from the source to the cell. And we did a table which gives a little view about how much power is produced by the cells. So this table can give us an idea about what cell is the best with and what sources is the best with. So, for example, the halogen is very good with cell duration and cell free, whereas the LED is better with the big cell and the flexible cell. So what we can say is that light is an infinite source of energy, which we should take advantage of. And the PV development is one of the main key problem in energy, which can relate on regarding global warming. What we have seen in this project is that indoor lights is a source of energy which we can use and we can take energy from. So is a new branch of the PV industry to develop and to work on in order to make better use of the energy and try to gain more efficiency regarding the future. So if you have any questions, and thank you for your attention.